Hi guys, welcome to Planet Moonshine, the channel where we use home distilling techniques in a professional brewery, and what we're looking to do is ask the question, can we make a product that people will buy? For us, living here in Spain, running a professional brewery, this is something we're able to do and do it legally and pay taxes on the product that we sell. So I know that can be difficult in some countries, but here for me it's fine. So if this is the kind of thing that is of interest to you, please stick around and watch the video. If you like it, giving me a thumbs up always helps, and if you want to subscribe, we'll do more of this content. In this video, we're going to look at doing a keg conversion, taking a 50-litre steel keg and turning it into a still, and using the right tools to do that job and showing you step by step how to do it. Okay, so we started with one of these. It's a beer keg. I have lots of them around because, of course, we're a professional brewery. So it seemed like the perfect choice for me to take one of these and turn it into a small still. I know lots of home distillers use converted kegs, and of course it's easy for me because I already own the kegs, so no worries there. Job number one is, how do you remove this guy? So this is a type A keg fitting, and it's spring loaded and very difficult to remove if you haven't got the right tools, but there are a few cheats you can do. The easiest way is to take a screwdriver, insert it in here underneath this piece of black and green rubber, and start to lever that out. You might have to break it to do it. It doesn't matter, you don't need it, you're going to throw it away. So you remove this rubber all the way around, and then what you're left with underneath is a piece of metal which was been capping the spring. And you get your screwdriver underneath that, and you lever that up and out. So after you've removed the rubber and the cap, it looks something like this. The spring is quite a hefty, heavyweight spring, so you have to be careful. And then you can fiddle with this spear to disconnect it. So this is what the spear looks like after you've taken it out, and you can see that here you have the keg head itself, and if you remove it like this, it releases the spear. Now this is a little bit difficult to do while it's still inside the keg, but you won't be able to get it out until you've done it. So you have to reach your fingers inside or a pair of pliers and fiddle with it until you can separate these two pieces. Then you can unscrew this top part, and then you can finally lift out the spear. Okay, so I just wanted to show you in close-up how you remove this spear. It can be a little difficult unless you know what's happening. See the height of it? It's almost level with the keg head. What we're going to do is we're going to get our pliers, lift it up, twist it, and then drop it down. And now you can see it's a centimetre or two below the level of the keg head. After that, all you have to do is unscrew the keg head, it lifts up, and then the spear, you have to wiggle it around a bit, and it just lifts out, and you can see there's a little tab on there, and that's what's stopping it from coming out. It's as easy as that. So now we have a keg that's had its spear removed, and we're ready to do the next step of conversion. For me, that means putting 3 holes in the keg. I want to have a drain port to drain the used dunder out of the keg. I want to have an electric heating element to heat up the contents of the keg and control it. and I want to have a cap on the top of the keg in order to be able to clean inside if it gets particularly messy. Now I've chosen tri-clamp fittings for all of these, and if you're going to make those holes, you need to have the right equipment to do it. So this is a bimetal hole cutter by a company called Starrett, who make particularly good products. A small one for the drain port, a slightly bigger one for the ferrule on the heating element, and a much larger one to make the hole for the cleaning port. As we'll see later, that didn't work out too well. Okay, so when you're doing this, you always want the hole to be ever so slightly smaller than the size of the ferrule that you want to either weld or braze or solder into place. Because what I've got to do now is basically file that to the correct size. I want it to be a really tight fit when this goes in, such that I have to basically soft hammer it into place with a rubber mallet or something like that, because if it is too loose, then when you try to weld or solder it, it'll just slip and fall inside the hole and you won't get the necessary clearance that you want. So start off with a hole that's too small and file it out to size. If you make it too big, you can't put the metal back. Okay, so this is the hole that I cut on the other side of the keg to accommodate the heating element. So to cut this hole, I used another Starrett hole cutter. This time it was a 44mm, and as you can see, the hole cutter goes nicely in the hole, but again, the hole is slightly smaller than the ferrule that I'm going to solder into place on that. Okay, so now we come back to the top of the keg, and by far the largest hole we've had to make. This was by far the hardest hole to cut. I have a large Starrett hole cutter bought specifically to do the job, and my little electric handheld portable battery powered drill couldn't do it, so I went for the Bosch, and it just wasn't up to the job. Both of these units, because of the massive amount of torque required, started smoking and basically burning out the drill. So I had to stop, and what I did then was I drilled a series of small holes in the indentation that the cutter had left, and then used a Dremel with a grinding disc, a cutting disc on it, to basically make very tiny cuts all the way around the edge, and that got through it a piece of cake, no problems at all. And now I've got to clean up that hole. Okay, so when it's done, this tri-clamp unit will go on the top like this, and if you look, you can see that I've cut away the edges of the keg here. Okay, so that was quite simply just an angle grinder, just down the sides here, and then from the inside, let's just move this out of the way again, going from the inside with my grinder just to take off that lip, and at some point I'll probably sand this down so that it's nice and smooth and doesn't have a lip. So there's a bit of cleaning up still to do, but you get the idea. Okay guys, so now all the three ferrules are a nice tight fit. This one for the heating element, and around here this smaller one for the drain port. So it's looking like a good job. Now we've got to think about brazing or welding. Okay, so I wanted to have a quick chat about attaching your tri-clamp ferrules, which are always made of stainless steel, to your keg, which is also made of stainless steel. Now, if you can do TIG welding, that's obviously the strongest and best way to do it, but many people do not have TIG welding equipment or TIG welding experience, and to do a good job takes both.
The next best option probably is brazing. But again, you need a very high-powered blowtorch and you need brazing skills and the right flux. So that leaves soldering. And the question is, can you solder stainless steel to stainless steel? Well, the answer is yes, if you use the right equipment. To solder effectively, you need the right type of solder, which is a high silver solder, usually 55% silver or better, and you need the right flux, which is specifically for stainless steel. I used these silver solder brazing rods, which have a stainless steel flux on them. This is a 55% silver from the UK, but you can get other types. And you need a hot torch. So you can use a normal propane torch, such as you would use for, I don't know, soldering copper joints in plumbing. But this is a MAP gas torch. I believe it's the same kind of neck fitting, and you can in fact use the same kind of torch to do your soldering work. But the gas canister, this yellow gas canister, is MAP gas. MAP gas is a mixture of acetylene and propane pre-mixed inside to burn with a hotter flame. And with these two things, you shouldn't have a problem silver soldering your stainless steel. So, just to show you a bit of the process, I've got two stainless steel washers here. I'm just going to put them one on top of the other. And what we're going to do is just solder them together, just to show you how easy it can be. So, we start off by adjusting our torch. I hope you can see this, but what I've got is a very focused blue point, sort of about here in the flame. And this tells me that I've got the optimum temperature. So we're going to just point the torch at our work. And all you really need to do this is patience. What you're waiting for is for these pieces to turn a dull red. Not a cherry red, not a bright red, just a dull red. And you want to focus the tip of that blue point on the flame on the work, the piece that you want to get hot. You can see it started changing colour a little bit. I'm just working the flame around it to try to keep building that temperature. Okay, it's just starting to go red, and what we're going to do, take our solder and we're just going to run a little bit of flux around the work. Okay, and we'll let that get hot again, and then just let the solder run into the joint. There it goes. And a little bit on this side. And we're done. Okay, so this is the piece that we just silver soldered together. I'm going to bring it in close so you can see that it's got quite a nice solder joint. It does in fact go all the way through to the other side. So these two pieces are not coming apart anytime soon. And it's just as easy as that when you solder the keg. Like I say, all that's important is that you need a very hot torch. And if you use MAP gas, that is going to be absolutely fine for the job. It worked for me. And the solder that you need to use is silver solder with a flux coating suitable for stainless steel. And the silver solder should be at least 55%. And after you do that, wait for it to turn dull red, apply your flux, apply your solder, and the job's a good one. Okay, all that remains is for us to take a look at the keg and clean up our work. Okay, so here we are. This is my keg soldered up with its top port, a drain port, and a place to put the element. So we're going to take a close-up look at these joints, and then we're going to set about cleaning them up. Okay, so this is the top port. It's not the prettiest job in the world at the moment because it still needs cleaning up. And I think there's probably a little bit of over application of solder. Take a look at the place where the heating element's going to go. Again, we've got a nice, clean looking joint all the way around. At the drain port, once again, perhaps a little bit too much solder, but it's a nice clean joint all the way around. Okay, so this is what it looks like after it's been cleaned up a little bit. You can clean it up with anything you have on hand that isn't going to damage the stainless. So you're okay with things like emery paper, a flapper disc, or a stainless steel wire brush, but avoid things that are made of non-stainless steel. So you don't want to be using something like wire wool or a steel brush that's not stainless, because all that's going to do is embed steel in the stainless steel and it will rust as a consequence. Okay, so what we're going to do now is fit our cap onto this access port with our okay, cap fitted. Okay, next job, drainage port. So I just put this here, like this. And we have drainage port. And finally, the heating element. So this is quite a simple job. Put on the gasket, slide in the fitting, and try clamp it into place. And there we go. We have got one complete, ready to use pot still for our home brewing. And I guess, as ever, we should ask the final question. Are we going to be able to make product with this still that people are going to buy? Hell yes. At least, I hope so. So, thanks for watching this first ever video from Planet Moonshine, and thanks for watching all the way to the end. If you like the content, please give me a thumbs up. It really helps the channel. If you have any questions, comments or suggestions, or just want to point out my inevitable mistakes, please make a comment, but do it in a positive way. We'd love to hear from you and give us tips and advice on maybe stuff that we could do next. I know the audio quality was a little bit variable in places in this video, but hopefully it got a little bit better towards the end. I'm still working on the whole production values thing. In the next video, we're going to take a look at the column itself. We'll talk a little bit about different types of still columns, why I made the choices that I made, and we'll take a quick look at how the whole thing goes together and an in-depth look at the individual components of the still. Then we're going to take a look at how we control power levels within the still, and we're also going to take a look at how we do the cleaning of the new still and how we sort of prep it for first use. So if any of that sounds interesting to you, please do subscribe, ring the bell, and you'll get notifications when the next video becomes available. So until next time on Planet Moonshine, keep chilling and keep on distilling. Peace out.